All right, welcome back, guys. Lesson 8.2. We're now going to use all the trigonometry that we learned last unit to find sides and angles of triangles, of right triangles. We will clarify that. So a couple things. First of all, you're going to start off a lot like last unit. You're going to choose an angle in your triangle. Remember, it's got to be an acute angle. Don't choose the right angle. You're going to call it theta, and then you're going to label your triangle. Now, if you have two angles in a triangle, you can always find the third, but my suggestion would be, look at this first example. They've already given you one of these angles, that's 64. So I'm going to use that. I'm going to call that my theta. And then I'm going to label my triangle according to that. So I always start with opposite. Again, I'm going to go across, call this side my opposite side. Across from your right angle is always your hypotenuse. That leaves this last side as your adjacent. All right, let's do one more thing. Let's put our SOHCAHTOA up here at the top of the page. SOHCAHTOA is going to help us to figure out which trig ratio we're going to use to be able to solve for the missing side. So basically, you're going to look, there's kind of one side that they're going to ignore. They don't care about one side. They give you one side. So notice they gave me the length of the hypotenuse, and they're asking me to find one side. They're asking me to find the opposite side. So we are going to use a trig ratio that involves the H and the O, because those are the only sides that matter to us. So we come up here to our nice little SOHCAHTOA, and we look for the H and the O. Notice how they're both together in the SO. So remember, S stands for your sine. So this one you're going to write the sine. Usually we write the angle theta, but this time they've given us the angle. We know that the angle is 64. So we're going to go ahead and write that the sine of 64 is equal to the opposite side, which is x, divided by the hypotenuse, which is 25. All right, and then we're just trying to solve for x, get it all by itself. So notice right here, this x is divided by the 25. So to undo that, let's just multiply both sides by 25 right there. And so x is just equal to this 25 times the sine of 64. Now, this is just a number that you can put into your calculator. Hopefully you all have some sort of calculator. There's all kinds online if you don't, so just Google scientific calculator, you'll find something, or use your phone. Your phone will even do the basic sign. Most of your calculators are already going to be in the mode of degrees, but if you're getting a different answer than I'm getting, please make sure to just kind of Google how your phone will put it into degrees. Okay, so in our calculator, we're just going to type in 25 times, where's my times button? The sine, you'll see the sine button on your calculator, of 64. And in my calculator, it gives me 22.46. Let's do 47. Okay, 22.47 is what that value is right there of that x. Again, kind of use just common logic as well. Make sure if it's a number that you're getting that's bigger than 25, just be a little bit wary because that hypotenuse should be your longest side. All right, let's look at the next one. Again, label your triangle. I'm going to use that as my theta. So across from it's the opposite. Across from my right angle is the hypotenuse. That leaves this lovely side as the adjacent. Okay, again, we kind of note, we know the adjacent side. They're looking for the opposite side. So we want a trig ratio that uses the A and the O. Notice right here, our TOA uses the A and the O. So we just set it up, the tangent of the angle. Now our angle here is 47, so the tangent of 47 is equal to, O is first, so that goes on the top, x over adjacent, which is 12. Again, now we just solve, get x by itself. We don't like the divided by 12, so multiply by 12. And in our calculator here, let's go ahead and plug it in. 12 times the tangent of 47 is equal to 12.87. We'll round it right there. 12.87, and we're done. Okay, let's look down here at this next one. I'm going to scroll up here just a little bit. Actually, then we lose our SOHCAHTOA, don't we? Let's just scroll to right here. All right, on this one, again, they've given us an angle, so call that theta. Label your triangle. So we've got the opposite, the hypotenuse, And last, we're going to write down the adjacent right here. Then we're going to say, okay, they're asking us to find the adjacent. They've given us the hypotenuse. So we come up here and we say, oh, look, the cosine is the adjacent over the hypotenuse. So we write our cosine of our angle, which was 18 degrees, is equal to A is first, so that x goes first, over the hypotenuse, which is 34. And we solve by multiplying both sides by 34. And so in our calculator, when we do our 34 times the cosine of 18, it gives us a value of 32.34. And that is our missing side. That's how long that adjacent side is. All right, these are going to be a little bit different. Most of the time, our x was in the numerator. Notice how the x was in the numerator, and then we divided by something. So to undo the division, we just multiplied. Let's look what happens on this one. Again, start off the same way. We're going to choose that theta to be the angle that they've given us. Across from it's our opposite. Across from our hypotenuse, or our right angle is the hypotenuse, and that leaves the other side as the adjacent. Okay, so again, they've given us the opposite side. They want the adjacent side. So we look up here to find a ratio that uses the O and the A. So here's my tangent right up here. I'm going to write that out as the tangent of my angle, which was 35, is equal to, O comes first this time. So that 9 is on the top over the adjacent, which is my x. Now this time, when our x is in the bottom, basically if you were to multiply by x, then you'd have to divide by the tangent of 35 to get x by itself. So I'm just going to tell you really quickly, just memorize to do this. It'll make your life easier. But you're just going to switch the tangent of 35 with x. So if x is in the denominator, just move it to the other side and move whatever was in the other side to the denominator where it was. So I have x here is equal to 9 over the tangent of 35. Okay, then again, calculator is going to do the rest of the work for us. We're going to take our 9, divide it by the tangent of 35. 9 divided by the tangent of 35 is 12.85. 12.85 right there. All right, last two. Same thing, choose your theta. So this is opposite. Across from my right angle is the hypotenuse. The other side's the adjacent. You don't really even need that because they give you the opposite. They want the hypotenuse. So we're looking for O and H. Notice right there, that sine, the S stands for sine. So the sine of our angle is equal to the opposite, 27 over the hypotenuse, which is x. Again, x is in the denominator, guys, so flip it up here with what's on the other side. So x is equal to 27 over the sine of 63. And calculator will tell us that 27 divided by the sine of 63 is equal to 30.30. 30.30 right there. All right, last example here. Here's my theta that I'm going to choose. Across from it's the opposite. Across from my right angle is the hypotenuse. That leaves us 18 as my adjacent side. Note, they've given me the adjacent. They want me to find the hypotenuse. So we're going to use that cosine right there. The cosine of 30, which my angle is 30. My cosine of my theta, 30, is equal to, now A is first here. So the adjacent goes on the top over the hypotenuse, which is my x. And again, like the others, if your x is in the denominator, flip it to the other side. X is equal to 18 divided by the cosine of 30. And so x is equal to, calculator, 18 divided by the cosine of 30 is 20. Oops. Let me write this a little bit better here. We're just going to erase that whole thing. X is equal to 20.78. If you have a calculator that tells you that it's 12 square roots of 3, that's fantastic. That's more accurate. It's not rounded. That would be fine too. But my calculator doesn't do that. All right, that's how you find side lengths.